Standard equation of an ellipse with the center at HK. So the question is now, well, what if it's not centered at the origin? What if it's centered somewhere else? So just like our parabola, our vertex is HK. If you look at our standard form equation here, it looks very, very similar. The only difference is instead of an x squared, you have an x minus h. And instead of a y squared, you have a y minus k. Also keep in mind, just like our parabola, h is with your x, k is with your y, just like before. But if it's a negative h, it's really a positive h. And if it's a negative k, it's really a positive k. Now, if you look at the other one, where your major axis is now on your y, the only difference, once again, is that the a and the b values change. So just like before, your a is always your larger number. A has to be larger than b. And if a is underneath your y value, then your major axis goes along your y-axis. If your a is underneath your x value, then your major axis is going to kind of line up with your x-axis. So let's take a look at this. Number 5, what is the standard form equation of the ellipse that has the vertices -2, -8, and -2, 2, and the foci -2, -7, and -2, 1? So I'm first going to start with drawing a picture so we can understand what's going on here. Vertices are at -2, -8, and -2, 2. Now, if those are my vertices, what that's telling me right there is that's my major axis. Okay, so my major axis, if I'm kind of looking at a really rough sketch of some sort of an ellipse, it's going to be looking, I don't know, something like that. And the distance from here to here, we're down at -8 up to 2, that's 10. Which means my center is somewhere in between. And if that's my major axis, I know that that's my a value. So I know a is 5 because you cut it in half. Now, if a is 5 and I'm down here at -8, I'm going to come 5 from that, which is going to put me at -3. So I know my center is, and that's a big C, because there's also little c. So my center is now at -2, -3, which is going to be really helpful. Now, the other information we're going to take from that are our foci. So our foci are at -2, -7, and at -2, 1. Now, if that's my foci, the distance, we're down here at -7 up to 1, that's going to be 8. So half of that, and that's your foci, not your minor axis, so that's C, is 4. So if I want to write the standard form of my equation, the last thing I'm going to need is my b value. So if we're doing a b value, remember that c squared equals a squared minus b squared. We know c is 4, so 16. A squared, keep in mind a is 5, so that's 25, minus b squared. If we take 16 minus 25, that gets us -9, equals -b squared. Divide both sides by a negative. Take the square root. We now know that b equals 3. If we're trying to write the equation of this thing, we're going to have x minus h squared over something plus y minus k squared over something always equals 1. Now, the reason I'm saying something again is because we have to figure out which one's the a and which one's the b. Do you notice that your major axis is vertical? Your major axis is along the y-axis. It's kind of like mirrored on the y-axis. That means that a has to go underneath the y, which means b has to go underneath the x. At this point, we're going to fill everything in. So x minus h, that comes back to your center. This is h, this is k. So if we're minusing a negative, plus 2 squared over b squared. We know b is 3, so that's going to be 9, plus y minus k. K is -3, so plus 3 squared, over a squared, we said over here is 5, so 25 equals 1. Example 6. What is the standard form, that's a typo, of the equation of the ellipse that has the vertices negative 3, 3, and 5, 3, and foci 1 minus 2 root 3, comma 3, and 1 plus 2 root 3, comma 3? Let's start with a picture. So vertices are at negative 3, 3, and 5, 3. Now, if those are my vertices, keep in mind vertices versus co-vertices, I know that that's your major axis, so our ellipse is doing something like this. If that's your major axis, that's going to help us find our a value. I'm out here at 5, I'm back here at negative 3, that's going to give me a total distance of 8, so I know a equals 4. If a is 4, I'm going to come from 5, I'm going to back up 4, 1, 2, 3, 4, which puts me at 1. So I now know my center is at 1, 3. We know our a value is 4. The next thing we know is we know our foci. So our foci are at 1 minus 2 root 3, comma 3, and 1 plus 2 root 3, comma 3. Now, 2 root 3, I don't really know what that is, but do you notice this guy's sitting here at 1? So that's already at 1. So I'm going to do 1 plus 2 root 3, 1 minus 2 root 3. So really, if you want your foci or your C distance, C is just 2 root 3 because you're already at 1. So that doesn't really matter. You're just taking this 1 and going to the left and going to the right. So we now know our C value. From here, we're going to use that to find our B value. So C squared equals A squared minus B squared. Keep in mind if you're doing C squared, you have to use parentheses because you have to square the whole thing. And then A we said was 4, so 16 minus B squared. If you take 2 root 3 and you square it, that's going to give you 12. Subtract 16 from both sides. Negative 4 equals negative B squared. Divide by a negative. Take the square root. We now know B is 2. At this point, we're going to start with our standard form. So x minus h squared over something. We'll talk about that. Y minus k squared over something equals 1. This time, our major axis is right there because we had our vertices and our foci. Your major axis is it's parallel to your x-axis. So we know the x-axis is the major axis. So this guy has to be A, which means this guy has to be B. And then we just fill in as we go. So x minus h. Our center is up here. This is h. This is k. So minus 1 squared. Over a squared, we know a is 4. So this is going to be 16. Plus y minus k. K is 3. Over b squared. And we said b was 2. So that's 4 equals 1.